In example 3, we are going to be looking at a blood drive. The Red Cross needs to be sure they get at least 20 units of O negative blood. O negative are universal donors, as I'm sure you're aware, and 7% of all people have O negative blood. So first thing, why is this a binomial experiment? Okay, why does this qualify as binomial? Well, one, okay, we have a success versus a failure. In this case, that would be O negative or not. Okay, it doesn't really matter what other blood types there are. When we need those universal donors, you're either a universal donor or you're not. Okay, and then second, we do have repeated, in this case, 20 independent trials. And again, your blood type has nothing to do with the next donors. So your blood type has no connection to another donor's blood type. Okay, so that's how we can justify that this is binomial, why we know it is binomial. So what should we define as a success? So you can actually choose whether you want it to be O negative is a success or not being O negative is a success, but they're looking for O negative blood. I'm going to stick with O negative blood is being a success. Okay. All right. If they are expecting 400 people to come to the blood drive, give the values for N, P, and Q. So remember, N is the total number of trials, so that is 400. P is the probability of success, so in this case, having O negative blood, 0.07. And then Q is the probability of failure, or in this case, not having O negative blood, 0.93. Now, once we've identified those values, we can use our calculators to find the probability that exactly 20 people have O negative blood. So this is our new calculator function. We've just done it one time in the last example. So this is where we're going to use our binomial PDF function. Okay, so remember that second VARS just under your arrow keys to the left of clear. Then arrow down should be A to binom PDF. And then you're going to see, again, trials. And so I'm writing this for those who don't have those little prompts. And this is still what you put on your paper, I mean, regardless, just to keep track of what you're doing. So 20 is the number of trials. Then you need to put in the probability that they have O negative blood, 0.07. And then, oh, sorry, not 20. Back up. 400 total number of trials. I'm looking at the 20 people right on top of that. 400 people, number of trials, 0.07, sorry, number with O negative blood, and then 20, the number of people we are inquiring about. Okay, so what is the probability that 20 people exactly will have O negative blood? Okay, so this is your N, this is your P, and this is your X. All right, so when you do that, you should get 0.023 as your answer. Okay, the next question says, is this an unusual event? So unusual, again, we've got 3 methods for telling, but here we have a probability. And so we're going to use that, is it less than 5%? If it is, it's going to be considered unusual. Well, in this case, since the probability that X is 20 is less than 0.05, this is an unusual event. Okay, so in other words, only 2.3% of the time when 400 people show up to a blood drive will we find 20 of them with O negative blood. And that's the exact interpretation of what it was we just figured out, okay, when it comes to that interpretation. So we're going to say if 400 people donate blood, the likelihood we have exactly 20 O-negative donors is 2.3%. Okay. And you can change it into a percent, that's fine. Okay. But again, your calculator is going to calculate the decimal version. So it's not looking very good. Okay. Not looking very good. But let's consider question F on the next page. What is the probability that at least 20 people have O negative blood? Okay, at least 20. So not exactly 20, but at least 20. So remember that word at least, or that phrase at least, that's a minimum of. So what we want to find is the probability that X is greater than or equal to 20. Okay, X is greater than or equal to 20. Now, I want you to think for a minute of what the heck greater than or equal to 20 means. Okay, so let me give you a little bit of a visual here. So when we start doing probabilities, we would start with nobody has O negative blood, one person has O negative blood, and we would keep going. Okay, we would eventually get up to 19 people have O negative blood, and that 20 people have O negative blood, and 21, and so forth and so on. And we'd have to go until we get to the probability that 400 people have O negative blood to get everybody. Okay, I want you to think of the stretch of people we are talking about when we say X is greater than or equal to 20. We are looking at 20 up to 400. That is a lot of binomial PDFs. Okay, that is a ton of binomial PDFs. And we don't want to do that. Okay, we do not want to do that. Obviously, that's crazy, right? That's like 380 different things we have to hit. And you'd be like, there's no way that she expects me to do this. You're right, there's not. There's not a way I expect myself to do this. So there's a shorter way, right? There is a shorter way. If what we want is the stuff that I just highlighted in pink, what we don't want is the stuff I'm now highlighting in blue. And since the pink and the blue total up to 1, okay, since they total up to 1, one of the things we can do, again, as a shortcut, is do 1 minus the probability that we have nobody with O negative blood, minus the probability we have one person with O negative blood, minus the probability that 19 people have O negative blood. We can do that instead. It's still 20 steps, y'all. I totally get it. But hey, it is a touch faster. Okay? So if we take out the things we don't want, that will leave us with the things we do want, is that X, number of people with O negative blood, is 20 up to 400, which is what we want. Okay? Again, that's still a lot of work. But here's the deal. I have a faster way to do the part that I just circled on your calculator. Okay? And so this is a new function that comes into play that we will also be using. Okay? The one we want to use is binom CDF. Okay? It is under second, bars, variables, arrow down. It should be B, binom CDF. Okay? This is the binomial cumulative probability distribution function. We don't put the P in there. CDF, cumulative distribution function. Now, you remember cumulative relative probabilities from earlier on when we started talking about probability distributions. We did the one scenario, and then we added the 1 and the 2, and then the 1 and the 3, 1, 2, 3, and then 1, 2, 3, 4, so that eventually it added up to 1. That's what this function does, okay? Binomial CDF adds up the probabilities from x equals 0 to x equals, I'm going to say little x because that's what we use for like our total number of how many we're looking at. From x equals 0 to x equals x, you define the limit successes, okay? So this is your maximum number that you want, okay? So notice it always starts at 0. The only exception, those of you with TI Inspires, you'll find it's a little different for you, okay? You can put in a min and a max. But for the 83, 84, it always starts at 0. So what we want to do is we want to subtract out the probability that 0 to 19 people are O-negative donors. That will leave us with all the other scenarios, that 20 to 400 people are O-negative donors. Okay, so on your calculator, we're going to first find binomial CDF. Okay, so we want binom CDF. 400 is our N, okay? 0.07 is our P, and our X is 19, okay? That's what we want up until that point. So when you do that, you come up with the value 0.0422, okay? Now remember, that is the probability that 0 to 19 people are O-negative donors, okay? What we want is the probability that we have 20 or more. So we want to do 1 minus 0.0422 to come up with the result 0.9578, okay? That right there is the probability we end up with at least 20 people being O-negative donors, okay? So how would you feel about telling your supervisor you would meet the goal if 400 people donate blood? Well, you need at least 20 units, right? You don't care if you have 20 exactly. If you end up with more than that, hooray. Better for the hospital, better for whoever's using that O-negative blood. You've got more universal donors, okay? So would you feel comfortable? I would say, yeah, absolutely. If 400 people show up, I've got a 95% chance, and higher actually, almost 96% chance that we're going to reach that goal of having 20 people with O-negative blood. Now, I know what we just did there in F can be a little confusing. You may need to rewind this video a couple times and continue to listen, okay? Draw the pictures, do whatever you need to do. Go back and look at some of the previous examples that didn't deal with 400 people, like we did at least one and we subtracted off like a single scenario, X is 0. Go back and look at some of those. Try, if you are not convinced yet, try to convince yourself why that works. And please write down whatever questions you have, okay? Write them down so that you start to remember. And then as you go through the rest of this section with me, see if you can start to figure out how to answer your questions. And then if not, again, great time to post a question or to ask when we meet together online.